Hello, Algebra 2. So I just want to do a quick review of everything that we've talked about having to do with matrices so far. And then rather than giving you guys guided notes, because I did not get a chance to make them with how quickly we just had to get everything together, I'm kind of just going to do some pencil to iPad notes. That way you can take them down while I take them down and we're all doing them together. But I may change my mind and decide to do some guided notes along with it as the weeks go on. So just kind of bear with me. If you have questions, please feel free to shoot me a message. I will have a couple problems for you to finish at the end of this lesson. So I'll probably upload those a little bit later after this video. And then you guys can complete those. It will be worth 5 points, just like the rest of the assignments for your daily assignments. Of course, we will still have quizzes and standard checks and tests along this 5-week journey. But as of right now, I just want to do some notes and kind of get you used to how things are going to go. Like I said, if you do have questions, please let me know. I will be posting on my Facebook and Instagram about an hour before I will go live. And that's your chance to kind of hop on and ask me some questions. So during that time, I will be answering questions from my other classes as well. If you guys would like me to do a live for just Algebra 2 students, I can do that. Or if you have further questions and need more one-on-one time, we can set up a FaceTime or like a just a one-on-one time with you and I, and that can be through Canvas, Instagram, or Facebook. So please make sure that you have followed me on Instagram and friended me on Facebook, as well as turned on all your notifications for my posts on those two sites, and make sure that your Canvas notifications are on. That will help you stay on track with where you're supposed to be. If I see that you are not doing what you're supposed to be doing, I will be shooting you messages. I will be calling home because school is not closed. We are just doing online classes. So without further ado, let's talk about matrices. So we started off this unit by talking about what a matrix was and how to identify the order, which was doing the rows by the columns. So that's, I filled out all the notes on my iPad so that I can upload these and you guys can have a copy as well. Then we talked about how to add and subtract things. Remember that we added the corresponding values to find the new matrix, and the two matrices had to have the same order, so they had to be the same size matrix. And then we did some example problems, and you guys practice that on your own. We then moved on to talking about scalar multiplication. So this is just when a matrix is multiplied by any number. We call that a scalar. And it results in another matrix that's the same order. So we did some examples of that, and then you guys practice that on your own. And then we put those two things together. We had some where we were just adding the matrices. We had some where we were just multiplying by a scalar. So we decided to put those together where we were multiplying by a scalar as well as adding the two matrices together. So we did 2 practice examples together, and then you guys completed 1 through 6 on your own. So like I said, you guys should already have these notes done. These are things that we did in class. But just in case you missed something or you missed a day and you wanted to get caught up, I am going to post these notes so that you guys can kind of follow along with me. And what I'm reviewing is going to lead into what we're going to talk about next, which is super duper important because it's how I'm going to relate matrices to the first part of this unit, which was solving systems of equations. So then we moved on to matrix multiplication. So we said it's only defined when the number of the columns in the first is equal to the number of the rows in the second. So then I drew you this nice picture, and the two numbers in the middle, that blue part, those two numbers need to be the same. And the outside numbers tell you the size of your new matrix when you multiply. So I then recreated what I had kind of done on the board where I had circled the rows and the columns and how they corresponded with each other. Also, over on this left-hand side, you can see an example of the numbers that I multiplied together, just in case you forgot how to do it by hand. Although I did tell you guys to download Calculator X, which I'll show you that app. It's this guy right here. When I click on it, it looks just like the calculators at school. You will have some ads up here, but we can still create matrices, find the determinants, and all that fun stuff. And I can show you more of that when we start to do some examples together. So then we basically just used our calculators when we were doing this, and we just plugged the two matrices into our calculators, and multiplied them together rather than doing it by hand. So we had practice with that. And again, if two matrices, if the columns in one and the rows in the second do not equal the same number, then the matrix is undefined. So that's what happened with this example here, number 3. You guys then practice a little bit more on your own. You guys did great with all of that. We did practice that for, I think, 2 days. And then we got into this stuff, which we practiced for a couple days, but one of the days I wasn't there. And with the ACT last week and everything, it was just a little bit crazy. So I really want to go through and re-talk about the determinant and the inverses. So the determinant of a matrix, of a 2x2 matrix, is the difference of the products of the diagonals. And we've talked about that. You guys have practiced that, and we've done it in our calculators. So the determinant tells us whether or not a matrix has an inverse. And remember that highlighted green part, this part right here. Determinants can only be found from square matrices. If it is not a 2x2, 3x3, 4x4, then we cannot find the inverse. So then over in that bubble that's the dotted bubble, it also gives us some rules that we should follow. So if the determinant does not equal 0, then my matrix has an inverse. If the determinant does equal 0, then I do not have an inverse. So there in the square box, I kind of just showed you, this is the basic format for how to find the determinant. Again, it's the difference between the diagonals product. And then we practiced it in this example here. And we determined that it did have an inverse because the determinant of it was not 0. So then I had you guys practice on your own. I just quickly did them and showed you whether or not they had an inverse or not. And then we talked about, well, what if I have a 3x3 matrix? That's not as easy. So we used the calculator, and I had you guys go through and find the determinants of all of these. And then we put those on the board, if you remember. And we just did the calculator with that. And if you forgot, just shoot me a message and I can quickly do a video on that, on how to remember how to put that into the calculator so that you guys can refamiliarize yourself with that. So the last thing that we talked about before we went on this little 5-week online course thing was inverse matrix. So for square matrices, we define the inverse. So it looks like that. We say it's a to the -1. And we say that it has the property that if I multiply my original matrix by my inverse, I get the identity matrix. So this is my identity matrix. So this is basically that property of 1. This is like doing 1/3 times 3/1 and getting 1. And we all know that 1 is something that we can multiply anything by and it won't change the number. That's that same way here with this identity matrix. I can multiply this identity matrix by any of my other matrices and it's not going to change the matrix. So then we said the inverse of a 2x2 matrix is found from the following formula. So we only did one practice with this, and then I just told you guys to hop on your calculators and do it. So the formula was as follows. You can read. I believe in you. And then we did that example there. So if A equaled the matrix 1, 2, 3, 4, then the inverse was 1 over the determinant times the matrix, and we ended up getting -2, 1, 3/2, and -1/2 as the inverse. So if our inverse is correct, that means that we could take our original inverse A and multiply it by this inverse here, and I should get back that identity matrix, which is the 1, 0, 0, 1 matrix. So then I just had you guys kind of plug these into your calculators, and you proved to me that when you multiplied the two matrices together, you did in fact get 1, 0, 0, 1 as your matrix. So I didn't want to show that, I just wrote that it had an inverse. We then used our calculator to find the inverse of some things. I didn't do number 4, sorry about that. So I had you guys first find the determinant to just figure out whether or not it had an inverse, save ourselves some trouble. And then we went in the calculator and found each one of those matrices. So the biggest part that I wanted us to take out of here was this part right here. Let me highlight this. It's going to be highlighted in orange. I want us to take away this part right here. That when I have my original matrix times my inverse, I get that identity matrix, which means I get kind of like the number 1. So going from that idea, I want to go ahead and start the notes for today. And basically what I want to talk about is some matrix equations and how we can solve them. So starting out, if we just had something like a regular equation and we had like 3 plus maybe x equals 5, we all know how to solve this. We have to do those inverse operations to undo things. So you would tell me, Miss Gronefeld, we're going to subtract by 3 on both sides and end up with x equals 2. Similarly, if I had something like 4x equaled 12, to undo that multiplication, we would say, okay, well, we're going to divide by 4 on both sides. So this is what we call using inverse operations. In those two equations, we're using inverse operations to solve for our variable. So solving matrix equations is really quite the same way. So let me come down here a little bit. And if I had this equation where I said 6, 4, -5, -5 was my first matrix, and I was multiplying that by some variable. I'm going to call it y. And then I added it to the matrix 1, 5, 9, -8. And I said that that equaled the matrix -7, 33, -1, and -28. I want to figure out how I would go about solving this. So this is just my basic matrix setup. I have a 2 by 2 matrix being multiplied by something plus a 2 by 2 matrix, and that equals a 2 by 2 matrix. So we're going to use that same idea of inverse operations to kind of go about and solve these matrices. And I'm going to solve for that variable y here. So the first thing that I'm going to want to do is get rid of this matrix. So just like up here, that 3, to get rid of it, I had to subtract it. Well, I'm adding this matrix circled in blue. So to undo that, I need to subtract it from both sides. So I'm going to subtract my matrix 1, 9, 5, -8 from both sides here. So when I do that, we know how to subtract matrices. This first part stays the same. So I still have 6, 4, -5, -5 as my matrix being multiplied by that variable y. And it equals, now I just need to figure out what these two equal when I subtract them. So I'm going to do -7 minus 1, and that would give me -8. And then 33 minus 5, and 33 minus 5 is 28. And then -1 minus 1 is -2. And -28 minus 8 is -36. So I have this new matrix. It's still a 2 by 2, and I could subtract them because they were both 2 by 2 matrices there in the orange and the blue, which helps me out a bunch. So now I have this lovely thing here, and I need to ask myself, okay, I have a matrix. How do I undo said matrix? What do I need to do to fix this? So remember I said that A times A inverse equals the identity matrix was going to be a huge part of this lesson. Well, here, my A, this A is my 6, 4, -5, -5 matrix. So I need to figure out what this inverse matrix is. I need to determine what that is. So what I'm going to do is I'm going to go here to my calculator. I'm going to click second matrix, just like I would on the calculators at school. We go to, oh, just kidding. Sorry. I'm going to click alpha. No. I have to figure this out. Miss Gronefeld, get your stuff together. Come on. Okay. I want to click second. Nope. Oh, gosh. What am I doing? Oh, okay. Here we go. So let me go back here so that I can show you guys what I did. So I'm going to clear out of this. I'm going to quit that. Okay. And then I'm going to click second. And do you see right here, it says F3 matrix. So I'm going to change this because my matrix is a 2x2. And then I'm going to click OK. And it pops up with that outline for us. So I'm just going to plug in my matrix, which I said was 6, 4, -5, -5. Oops, didn't put the negative. And then to find the inverse, we take it to the negative first power. So I just clicked that caret key and then entered in -1, just like you guys have done. And then I'm going to click enter, and it's going to give me this lovely, nice matrix here. So I'm going to take this matrix, which is 0.5, 0.4, -0.5, -0.6. And let me just write that down. So I said 0.5, 0.4, -0.5, and -0.6. Am I correct there? Let's see. 0.5, 0.4, -0.5, -0.6. Yep, we got that. So to undo this, I need to multiply by my inverse matrix. So to undo and get that variable by itself, I'm going to multiply by my inverse matrix on both sides. So this side of the equation and this side of the equation both get multiplied by that. Okay. So my last step here is to just go ahead and multiply these two equations. So I'm going to multiply this guy by this guy. Okay. So we're going to go back to our calculator. And let's see if I can copy and paste. Oh, yep. Times my other matrix, which was -8, 28, -2, and -36. So alpha matrix, it's a 2x2 matrix. What did I say? -8, 28, -2, and -36. And then I get this lovely guy right here. So that is what my y is going to equal. It's going to equal this matrix right there. All right. So we said that y equals -4.8, -0.4. (5.2), 7.6. Okay, so we had to learn how to solve in order to be able to do all of these problems that we're going to end up doing. So I'm going to take what I've done up here. So just basically just like solving this matrix from that orange problem down. And what I want to do now is I want to apply that to other properties and systems of equations. So I'm going to go ahead and pause this video. I'm going to end up uploading 2 videos today. So I want to pause it here, and then I'm going to go back and I'm going to tell you how to do systems of equations with using